Okay, so this is a relative rate question. And relative rate, again, you'll find the relationship in the data booklet. You see it here on the axis, rate equals 1 over time. So relative rate equals 1 over time. Again, you can see that written as a triangle with your 1 here, your relative rate, and then your time here. So we see that as one of our triangle relationships. So if you're trying to calculate relative rate, it's 1 over time. And if you're trying to calculate time, then it's 1 divided by relative rate. So the question asks us here to calculate the reaction time in seconds when the concentration of reactant was 0.5 moles per litre. So we've been asked for a reaction time. So we've been asked for time. So time equals 1 over relative rate. So our challenge is to use the graph to find relative rate. So I go to 0.5 here, and I can carefully bring up my line here. And then I go across, and again, I can carefully bring my line over here. So I can see that at 0.5 mole per litre, the relative rate is 0.2. That's not the time in seconds, let's be clear, that's the relative rate, so it's 1 divided by 0.2, which gives me 5. Now it does tell me the units of time as seconds, so I can write S for seconds, but the other way to look at your units is to look at the units of the relative rate here. And the units are seconds to the -1, therefore the time unit is simply seconds. If it was MIN to the -1 for my relative rate, then my time unit would just be minutes. I've got a second one here, I've got a second example here. And this example gives you temperature and relative rate, so that's the shape we would always expect with a relative rate and temperature. What a relative rate and temperature graph shows you is that if you have a small increase in temperature, then it can result in a much larger increase in rate of reaction, which is why we don't have this directly proportional relationship, the same as we do have with concentration. Okay, so this time it's telling us that the reaction took 12.5 seconds, and we're asked what temperature was the reaction carried out at. So again, we have time here. Now we've been asked for the temperature, and on the axis here is relative rate of reaction. So for me to work out the temperature, I need to know relative rate of reaction. So relative rate is 1 over time. 1 divided by 12.5 seconds, so I can put my 12.5 in here, and 1 divided by 12.5 equals 0.08. So this is my relative rate. So what I now do is I go up to my 0.08 here, and I can carefully bring my axis, my line along here. And then I can then follow the line down here, and I can look at my temperature here, and my temperature here is 66 degrees. So the answer would be 66 degrees. So 2 similar questions, all to do with my triangular relationship of 1 relative rate and time. So I'm either calculating relative rate given time, so 1 over time, or I'm calculating time, which is 1 over relative rate.